Checking a variable valve timing system using the USB Autoscope. We are checking the variable valve timing system on a Kia Ceed 1.6-liter 2013. Connect the power cable to the device. The black alligator clip must be connected to a metal part of the vehicle chassis. The red alligator clip is connected to the plus terminal of the battery. The test requires a timing signal from the ignition system. This vehicle is equipped with a coil-on plug ignition coil. In order to obtain the timing or sync signal, we remove an ignition coil and, using a high-voltage extension wire and a suitable adapter, connect the ignition coil's high-voltage output to the spark plug. Make sure the electrical connections are reliable. Connect the synchronization probe connector to the InSynchro input. The sensor is attached to the high-voltage extension wire. The connector of the first universal cable is connected to the input number 5 of the device. We connect the back probe pin to the signal wire of the crankshaft position sensor connector. The connector of the second universal cable is connected to the input number 1 of the device. We connect the back probe pin to the signal wire of the intake camshaft sensor connector. The connector of the third universal cable is connected to the input number 2 of the device. We connect the current transducer to one of the control wires of the intake camshaft VVT control solenoid. The connector of the fourth universal cable is connected to the input number 3 of the device. We connect the back probe pin to the signal wire of the exhaust camshaft sensor connector. We connect the fifth universal cable to the input number 4 of the device. We connect the current transducer to one of the control wires of the exhaust camshaft VVT control solenoid. On the oscilloscope start screen, we open the menu Modes to 8-channel. Start the engine. On the oscilloscope screen, we observe signals from the connected sensors and VVT solenoids. Let's mark all the signals. Channel 1. Inlet camshaft sensor. Channel 2. Inlet VVT solenoid. Channel 3. Exhaust camshaft sensor. Channel 4. Exhaust VVT solenoid. Channel 5. Crankshaft sensor. Channel 6. Not used. Channel 7. Synchronization probe. Channel 8. Not used. You can see the names of all the channels in the drop-down menu. We turn on the recording of signals. We smoothly open the throttle valve and, upon reaching 3000 RPM, close it. After the idle has stabilized again, we quickly open the throttle valve until it is wide open. Until reaching 3000 RPM, turn off the ignition. Stop the recording. We see the recorded signals on the screen. We can change the signal sweep. We call the function of automatically setting the gain and offset of all channels. Call and run the CSS script. In the script configuration window, specify the channel of the crankshaft sensor and sync channel. Specify the number of the synchronization cylinder. Specify the signals that should be displayed in the Phase tab. The intake camshaft sensor, VVT solenoid of the intake camshaft, the exhaust camshaft sensor, exhaust camshaft VVT solenoid, and start signal analysis. The script first displays the cylinder efficiency tab. Next comes the ignition timing tab. Tab toothed disc of the crankshaft sensor. The Phase tab displays the intake camshaft position sensor signal. Turn on the display of the graticule. It can be seen that during the first and second throttling, the angular position of the intake camshaft sensor signal changed. The next Phase tab displays the intake camshaft VVT control current. The change in background color from light to dark indicates an increase in VVT valve control current, which was the reason for the change in intake camshaft angular position that we saw on the previous Phase tab. The next Phase tab displays the exhaust camshaft sensor signal. The angular position of the exhaust camshaft also changed during throttling. This is the response of the VVT pulley gear to a change of the control current of the exhaust camshaft VVT solenoid. Based on these diagrams, we can conclude that the VVT system is working properly.